All right, we are recording. Okay, so first and foremost, I record my lectures for you guys, which led to me making a lot of changes into the way that 2168 is done. The biggest one is that this is a flipped class, which I sent out via the announcement. I'll explain the details of what that means for you, but I've felt that basically for a lot of people that last semester that was really well liked. Some people didn't like it, but you know, it's also the first time this is now the second semester I'm trying to do this. So, all right, but welcome. So this is 2168. Really, did I completely forget to update the? Come on, that's embarrassing. Okay, so the purpose of the course is to teach you about data structures. So this is basically where we start moving into the more theoretical aspects of programming, learning how to organize data and different ways of organizing data. To do this, we are going to learn about some more advanced Java features, such as generics. We're also going to make heavy use of inheritance in this course, so hopefully you remember about inheritance from 1068. If not, do not worry, because guess what? Our first week is going to be reviewing inheritance. So we'll be reviewing inheritance and polymorphism for our first week. And then once we've got a solid grasp of that, we're going to move on into learning about our first data structure, which is array lists. And that will basically be manipulating these essentially lists that basically are much more powerful versions of arrays. We'll learn about time complexity, linked lists, stacks, queues, recursion. We'll be doing a lot of mazes and chess kind of style problems for this. Trees, heaps, Huffman trees, sorting algorithms, hash tables, and graphs. So this is a flipped class, meaning that I have pre-recorded basically the content for this course, and it's already on this playlist on Canvas on YouTube, ready for you to watch. I will tell you what you're responsible for each week. But in general, it's about, I don't think I exceed more than 2 hours any particular week. And that's just simply my first pass through. As I go through and make better passes, this course will have less and less time. The ideal time is to get it down to like an hour and a half each week. But the idea is that it's less than what you would listen to me droning on here in class is kind of the idea. Now, you watch those lectures at home, but it's not like an online course, right? Because an online course doesn't have a in-place meeting component. So the entire purpose of this is that instead of doing the vast majority of your homework at home, slamming your head against the keyboard because you forgot to put a semicolon somewhere, right, and then trying to figure out what that was, or you get an array out of bounds exception that you can't solve for 3 hours, you're doing the vast majority of your work in here, and then I'm able to point that out, and you're able to get back on track in like 5 seconds, right, is kind of the idea. We do have a TA for this course. He is recovering from an illness, so he is just not here today, but he will be here basically in this classroom pretty much every week. And the idea here is that these lectures are going to be essentially additional lab time for you to work on. So you would maybe take a small quiz, we'd review the content, then take a small quiz each week, and then use this time to work on your homework or to do some other in-class activities, right? So the idea here is active learning. The idea here is for me to get more one-on-one time with you guys rather than just you guys listening here and having basically me drone on and performing the entire time. I don't need to do that. It's much more valuable for me to work with you individually, to get to know you as people, to basically work on what you specifically need. And that's the entire incentive. I want to be able to work more with you guys. And I just can't do that with office hours and the lab time to the degree I'd like to. So that's kind of my incentive for flipping this. All right, so time and place. Congratulations, you have found it. So, I mean, it's kind of a silly part of the syllabus to have anyway, since it's in your schedule. But I'm mandated to have these in. Your labs are, I believe, tomorrow, right? Tuesday at 9 a.m. and Friday at 12 p.m., right? In those rooms. So there's only 2 sections for this. And then you should have gotten a C in Math Concepts 1 and in 1068 at the very least. If you got a C in 1068, you may not be prepared for this class fully. It is quite possible that you get hit like a hammer within the first couple weeks. But not to worry, that's what the first week is for, and you'll be able to figure out what you need to do today. The textbook is Data Structures, Abstraction and Design Using Java by Kaufman and Wolfgang. It is a good textbook. I don't really care what edition you have, but I've switched to the third edition because it was less expensive than the second edition, oddly enough. But it's a fairly good textbook, and I will be trying to go through the vast majority of it. The only one we're really not going to hit is Chapter 9, just simply because there's just not enough time in the semester. My office hours, my office is Circ 349. My office hours are on Monday from 3 to 4, and Tuesday from 4 to 5. Now, you don't need to send me an email saying, hey, can I show up to your office hours? Those are the times where you can just walk in, right? And then you are my number one priority. Well, in fact, my job is teaching you guys, so you're always my number one priority. But basically, these are the times where if you walk in, I am dedicated to, and I will be there. So Monday 3 to 4 and Tuesday 4 to 5, I chose them just simply so that they would not conflict with any labs, and also that they would have, hopefully that if you can't make one day, you can make the other day. Now, if you cannot meet with me then, I'm always available by appointment, right? So in those cases, if you need to meet with me at any other time, then send me an email asking if you can meet. And if for some reason, like you are doing this weird commute thing, I can meet via video chat, pretty late into the evening if you need to, Our TA's information is here. He has office hours from 10 to 12 on Wednesday. So, right before class on Wednesday, he's able to meet. Now, attendance is expected for both the lectures and the labs. If you arrive late, just don't make a big deal about it. But it's okay if you arrive late, and if you have to miss it, just let me know. There will be quizzes, and if you miss a quiz because you couldn't attend, just let me know. Also, similarly, just because I want you to attend here doesn't mean I want you if you're sick, right? I've got a toddler at home, so, I'd rather not share your germs with him. So if you're sick, just simply, just chill out. I'll trust you that when you say you're sick, and try to do your best to catch up on the content. I'll record what we do in class, which isn't that much, and I'll upload it if it's important, which, but most of the stuff is already there online. So, okay, academic honesty. I had to deal with this last semester. Don't cheat. Just really don't. And but we need to define that because, as computer scientists, we sometimes, or programmers, I might go on to, onto the internet and then head to Stack Overflow and type in how do I sort an array, right? Or something like, how do I bubble sort, right? Right, like that, and it'll come up and there will be some code, right? So what is cheating? Basically, if you copy somebody else's work, in whole and in part, somebody else's work, then that's a 0. Specifically, if you present it as your own work, right? If you need to find, now there's only so many ways to skin a cat. That's not really a fun phrase. Anyway, there's only so many ways to do a particular piece of code. Sometimes if you find something online, your best bet is to just cite it, right? And if you find, that's like 3 lines that specifically solves my problem of how to open up this file, right? Right? That's one thing. So when in doubt, give it a citation, because then it's not plagiarism, okay? But presenting this own work as your own, that's a bit of an issue. Yes?
So for small components, utility methods like that,
yeah.
You want just the Stack Overflow link?
You could give me a Stack Overflow link or something like that. Generally, though, it's best to try stuff on your own. And for most part, it should be able to be solvable, especially if you come and ask me. But when in doubt, give me a citation, especially if you've just copy and pasted it. And my response to that is don't copy and paste. Try to rewrite it and make it your own code, right? But presenting something as your own is the big thing. Yes?
But in terms of like if it's our own work, like if we're pulling information from a previous program we wrote.
Oh, of course that's okay. Yeah, I don't believe in this whole self-plagiarism thing. That's really weird. And it also, the other thing I should mention is that this is also slightly complicated by the fact that I'm actively encouraging you to work together with other people, especially on the first assignment. So I'll get to that in how we handle our assignments. If you have a disability and you need accommodation, please just register with DRS and let me know. I am very cool with that, and I will basically try to make sure I can give you the best experience you can. All right, so grading for this class. So in general, about a third of the class generally gets an A in this class. And then about anywhere between, about a fifth of the class, which is really good because it used to be a fourth. Anywhere between the fifth and a third, depending on the semester, will get a D or lower. Last semester was a fifth, so that was great. And that's that's between people who withdraw, get a D, and get an F. Most people who get an F just generally don't show up and don't bother even trying, right? They don't turn in homeworks. They then come into the exams and they get like 30s on the exam. So of course they're not going to do well, right? So generally, if you make your best effort, you are going to pass the class. The letter grades are no higher, right? Generally, if you've got a raw score of a 90 or above, that's an A. An 80 or above, that's a B. And 70 above, that's a C. And I adjust that at the end of the semester based on how things are graded. So like last semester, a 90 and above was an A, but an 88 and a half and above was an A minus, right? So that's how I did that one. And then I think it was like a 78 and above was a B minus. I can't remember the specifics for that, but I remember an 88 and a half was like the cutoff for an A minus last semester. So just keep that in mind. So the weight, I used to do these things called time labs. I tried it for 2 semesters. The results were overwhelmingly negative. So we are not doing that anymore because I listen. So quizzes are about 10% of your grade. Quizzes are basically anything that basically is done in class or in lab for a very short turn-in time. So you do it in class and you're expected to have it done by the end of class. So these can be some in-class exercise or they can be quizzes on Canvas, right? Which means they'll be done on your phone or on your laptop. By the way, if you have a laptop, you should bring it to class. So labs and assignments are about 25% of the grade. Labs and assignments are the same things. I'll get into that. And then your exams make up the bulk of the grade. My time labs were an attempt to make the exams less, a huge portion of your grade, but exams are pretty important. They're the way I can basically test you on your information. So exam 1 is worth about 20% of your grade. Exam 2 is another 20% of your final, is a quarter of your grade. These exams, exam 1 is considered to be, the first exam is always a bit weird because, you don't know what's going to happen. The first exam, though, is not too bad. It's a bit nerve-wracking just simply because it's the first exam. The second exam is considered to be quite easy. The last semester, the average score was 89 on that one. So, and then the final exam is considered to be quite grueling, where the average grade's around like in the mid-60s. So the final exam is not hard in itself because of the content in it, necessarily, mainly because it's a cumulative exam, and you've got 2 hours to do it, and it's Tuesday in the second week of the exams when you're probably focused on getting other final projects done. The main feedback I get from students who do poorly on the final is, I should have studied more for the final, or, but the final tests, can you actually code, right? And that's why the vast majority of people who took a beating in the final last semester, it was because they had trouble coding. They couldn't code. A lot of them got the theoretical concepts, but I really do emphasize can you code. It's about 50 points are the theory, and 50 points is the practical. And also, there's no escaping the final by going to a different section. I write the common final. Now, that being said, I do make sure that you guys are very well prepared. For exams 1 and 2, I give you a practice exam where that is, and I guarantee you get it a week before the actual exam. That is essentially, if I generally make 2 exams, give 1 to you as a practice exam. That's the way it works. So that's especially helpful for exam 2, because with exam 2, I give you, the questions are simply just the same questions, but with the numbers changed, pretty much. So, all right. So labs. So most of your time here will be working on assignments and labs. You get about 1 every week, and generally I have this whole 6 a.m. turn-in time. Point is, if it's a couple hours late, I don't really care. But generally, the due dates for each exam will be posted online as part of the assignment itself. The lab sessions and the time in class is pretty much, the lab sessions specifically are dedicated time for you to work on assignments and collaborate with your classmates. Your priority should be to work on the current week, not the previous week. So the main thing is, of course, this is much more of an issue for basically 1068 or 1051 or 1057. Make sure it compiles, right? But that's generally not an issue with the class because you got to demo your work for a credit, okay? So here's how the turn-in thing for your assignments work. First, you submit it online to Canvas. That gives you a timestamp to say when you turned it in. This is so because also I have a very lenient late policy. I like your late work. I like you turning in your work because late rather than not turning it in at all, because I want you to turn in your work. I want you to get practice. Okay, so it's 5% per day. If it's late, that's 5%, not 5 points, right? So first day will be a 95. Second day will be a 90.25, and so on and so forth. And generally, I cap the losses at about 50%. Right, so once generally you can turn it in late, and you're guaranteed to get at least a 50 if it works. Okay, and this also applies for part assignments that are multi-part. Right, so if you did like 4 of the 5 parts, right, on time, you get credit for those on time. And if you turn that last part a week later, then that will be 7. Then that last part will be 7 days late. Right, so I try to be as fair as possible about this. Okay. Because I want you to do your work, okay? So the second thing you have to do is demo it. Now, it's not when it's late is based on when you turn it in, not when you demo it, because there might be a queue, right? And you may not be able to demo it to me. But demoing the work to me or the TA, this involves running the code on your computer, showing me that it works. I'll ask you some questions about it, and you've got to be able to answer those questions, right? It's generally not too nerve-wracking. I've explained about the exams. Your first exam is generally on week 5 or 6. The second exam is around week 10 or 11. This is week 1. All right, and that's about it. So, any questions? Okay, great. So let's go ahead and start with your first assignment. Okay, so your first assignment is actually a pretty good review assignment, and it can be found online on Canvas. It's called the Fox and Wolf assignment. Now let me go ahead and show you what we got here. So I'm going to just compile it. Let's see. All right. So let's take a look at this. This is the Fox and Wolf assignment. If you download the code and run it and put it into your IDE, this is what you're going to get. All right, so this is a very badly drawn field, right? So here, this red dot is the fox, okay? This brown dot is the rabbit, and these dots and these blobs over here are bushes, right? This is a bounded field. It doesn't work on Pac-Man rules. It's not modular, right? So these are basically a boundary. You can't go by the boundary, right? So the idea here is that the fox hunts the rabbit, all right? And the fox's turn is to objective is to go and eat the rabbit, right? Have a nice tasty rabbit meal, right? And over here it says it's a bit small. The fox eats the rabbit after 25 turns, okay? So, and the board is, by the way, completely randomized. So the fox has an algorithm. It's a couple of if statements, so it's a bit. So I wouldn't really call it an AI, but it has a bunch of if statements that tell it, hey, if I see the rabbit, I'm going to go in towards the rabbit. You know, if I can't see it, I head towards its last known position, right? So it goes and looks for the rabbit, and it pounces and eats the rabbit, and it does so in as quickly as possible, right? The rabbit's objective is to survive for 100 turns. Once it survives for 100 turns, it successfully evades the fox and gets away, right? Now, I give this to you as a full and working program, so you can actually look at the code for the fox. Sorry, whoops, wrong one. Fox, right? It says, hey, can I see the rabbit now? Have I seen the rabbit? What's the distance to the rabbit? What's the direction to the rabbit? What's the current direction I'm moving, right? And then it has this function called the side move, which what it does is that it looks around for the rabbit and says, hey, can I see the rabbit? It uses a bunch of functions, which I'll go over, to find that rabbit and, and do this. So let's take a look at the rabbit code. It decides, I'm going to move in a random direction. This is not really a good strategy for survival, right? It's just going to move the rabbit just simply moves in a random direction. So your objective for this assignment is to make a better rabbit, right? It needs to survive, an actual portion of the time. Because since it's moving randomly, that fox is pretty much going to get it every single time. Okay? That is your objective for the assignment. Your grade on the assignment is, in fact, based on how often your rabbit survives. I have this handy-dandy grader library right over here, which we will compile and run, and it runs 300 simulations of this, and the rabbit successfully survives 1 out of 300 games, or 0% of the time, so that's a 0 for the grade. Your grade is the percentage that your rabbit survives based on a square root curve, which means it's the square root of the percentage it survives times 10. So if it survives 1% of the time, square root of 1 is 1 times 10, then that's a 10 for the grade. If your rabbit survives 64% of the time, then that's square root of 64 is 8 times 10, that's an 80. If it survives, so 64 is a passing grade there. So if you get if it survives 81% of the time, then that's a 90 for that grade, right? So it's a square root curve. So, it's very easy to see very small improvements in survival result in large improvements to your grade, in other words. Now, I did not come up with this assignment. I have stolen it from this guy, and as such, I have credited in the actual assignment write-up. There's a nice large PDF where I go over everything. But everybody kind of understands the objective here. We want to make the rabbit survive. Now, based on how this went last semester, I will give you a nice big hint here, which is that you don't necessarily want to try and copy the fox code and reverse engineer it, because that's a predator's code, right? The prey wants to run away. The objective here for the rabbit is that it wants to make sure that it can evade the fox and stay out of the line of sight. Now, how does that work? Well, let's take a look by looking at the fox code, right? So the way it decides to move, which is the only thing you need to work on, by the way. This is a very large project, but you only have to work on one small portion of it, which is this single function over here. And this is why I like this. It's a large project, but you only have to work on a small component of it. It's already a working program, right? To run it, you run the rabbit hunt, and it uses what's called a model view controller paradigm, which is a very common paradigm to use for stuff. You've got the model, which is the internal way that the code is represented. You've got the view, which is how I can see the code, or see a representation of the code, right? So over here, right, I'm running this, and right? The model is like kind of the internal steps over here. The view is this grid over here. And then we've got the control, which are these buttons that I can press to control the board, right? To get it to start and stop, right? And by separating it into those things, I can handle the way this works. Now, it also uses inheritance. The rabbit is an animal, which means it inherits all these methods that an animal can do. What can an animal do? It has a look function, so it can look. It can find the first thing visible in a, it can find the first visible thing in a given direction, starting from this animal's current position. So, and then the integer is a direction. What are those directions? Well, if we look at the model class, and again, all this information is in a big PDF that I gave to you. And by big, I mean it's like 4 pages. So not that big. But like there's coded, the numbers are hard-coded into model so that you can use them, right? So you can use model.n to look to the north. In fact, let's go ahead and just do that right now. I'm not going to really change the code, but I'm going to make my rabbit look to the north. I'm going to say this dot look model dot n, right? And we'll be able to see basically that every turn the rabbit will look to the north. Hold on a second. I think I actually got an error. What was my error? Main method not found in rabbit class. Right. Okay. So can't run that. Okay. So there we go. Right. I've got to run the rabbit hunt, not the one there. So now if I change it to step mode, right? Those yellow beams, that's the fox looking in every direction. So we see just there that there was a yellow beam that came out of the rabbit, and that was it looking north. Right. Let's go ahead and see that's the fox looking. And it doesn't always play for some reason, mainly because of the speed. I think it's because of how it has to render, right? And that was the fox, and that was the rabbit looking north, right? So I can use that function. Now the rabbit the fox does a loop to just look in all the directions. So it's got the 8 cardinal directions for it, which means, by the way, if you think about it in terms of a grid, that fox has a pretty large blind spot. It has actually multiple large blind spots, right? So we've got this, the fox looks in this direction, and it looks in this direction, diagonal, which means that this triangular portion is pretty much invisible to the fox. So that's something to incorporate into your strategy, by the way. So let's see. So that's how the fox works, and the rabbit. The rabbit hunt sets up the grid, and it sets up the model, the view, and the controller. Again, you don't really need to look at the model and the view. The view and the controller. The model has some useful functions for you. It has all these things, these directions, the minimum direction, the maximum direction. It has variables for, I see an edge, or I see a fox, or I see a rabbit. You're probably not going to see another rabbit, though, right? I see a bush, right? So it has those things to say what I can see. And then it's got a couple of other functions. It's got distance, right? It can tell you the distance from, right? So there's look, but you can also get the distance in a direction, right, as well, right? So look tells you what's in a direction, and distance will tell you how far it is. Also useful. And then there's this static method called turn, which given a direction gives you another direction. So for instance, if you see the rabbit, so if you see the fox in this direction, if I calculate turn 4 from that direction, that will give me this direction, which is directly away from it, right? So the direction is the direction that I'm saying I want to turn from, and the number is how many 45-degree rotations I want to do. So passing in 1 would make me face this way, passing in 2 would make me face this way, 3, 4, 5, 6, and it does accept negatives, right? So that's pretty cool. Does animal have that? Animal has look, distance, and can move. Okay, so you can call model's turn method, right? Because it's a static method, so you can use it by calling it from model. So that's so all the methods you need are right there for you. Now, so very simple strategies, just simply like not running directly towards the maw of the fox does help with your survival. The first thing you want to do, the first thing I would do, by the way, is if I see the fox, run directly away from the fox. Now, this won't work for very long because you're going to hit an edge at some point. So you'll want to handle that. The other thing after that is if I see the fox, maybe not move directly away, but move diagonally, because that gets me out of the line of sight, right? But the first thing you want to try to do is try to get this program working. So I know I've eaten up a lot of time for this class, but it's the first day, right? So that's just happened. Actually, I only ate up in half an hour, so that's pretty good. So we've got an additional 50 minutes. So last thing for this project, it is a paired project. So you get to work with somebody else. And not only that, you get to demo it with somebody else. So two of you can basically demo the exact same code, right? So two of you can work together. You can demo the exact same code. You can turn in the exact same code, and it's perfectly fine for this project. In the next homework we'll be doing, you can work with somebody else, but you have to demo separately and you have to turn in different code. Okay? But for this one, work with somebody else. All right, so I'll go ahead and help you all get set up on this project. So